Precast is a versatile structural material. It can either form up a column, wall, or even a flooring system. Although it's so versatile, there is some key design considerations that you will need to consider and add to your designs. So I'll be going through the key design considerations when you're designing each of these elements so you don't miss them. My name is Brendan, your structural engineer. Now let's get into it. Probably the most common place that you see precast chosen for different elements is in walls, as it has a fully finished solution. It comes together completely finished as a precast design. So it already has the reinforcement in it, it potentially has the outer finish on it, and it already forms up that wall and the barrier that you need. They can also be in a number of varieties. You can either have them as a load-bearing element, where they're stacking on top of each other and providing both lateral and gravity force resistance, or in low-rise structures. As an external cladding, as you can have a big steel frame around the outside and have it just cladded on the outside. But there's a couple of things that you need to consider. In that low-rise solution, you need to make sure that you have enough robustness in your design. This comes in a number of different forms. Firstly, you build your building up, and you need to make sure that it doesn't fall out. As there are a big precast slab up in the air, you want to make sure you're not going to squash people from the outside. So something you need to carefully consider when detailing it, especially in a heavy element, that you've got at least 2 areas of support. So what does that mean? Typically in a steel structure, it means that you need to have bracing around all the outside. You don't want to lose just one of those steel braces and have enough weight to topple the building. So you need to have double redundancy. Alternatively, if you can't do that, you may need to have a fixed base. There's a couple of problems with that as you're trying to resist the weight and overturning of a big element above you. So typically you go with the lighter solution, which is having additional bracing in the structure above you. But this comes more into play when you're talking about a fire situation. So you have your wall up here and a fire on one side. The area that the fire is on, it's heating up the concrete. This causes that area to swell up and bow out. This causes additional stresses in your design due to that expansion and bowing out. Now, what you don't want to be doing is having the firefighters come and that precast toppling on top of them as they're trying to fight and save your building. So you need to make sure you're carefully detailing so when that structure bows out, it also has enough strength in the steel structure to pull it back as the steel weakens in strength. There's a couple of ways that you do that. Firstly, you've got your column coming up. And if you tie it directly to your structure, you can have a lot of forces that can rip it apart and cause a lot of damage. So typically you need these things called fire ties. They have this bow in it, so as the structure bows out, it allows it to expand and not completely rip off the column. The other thing that you need to do as well is make sure that you've got enough tie capacity in the structure over the top. Now the way you do this is you put the wall on a certain angle, roughly about 10 degrees, and have a vertical load at the bottom here. This is causing a rotational movement. So you can look from the bottom, now you've got a moment, so now you can design for the force at the top here. Now it's not just designing for that single force, for that rotation for each precast panel. You need to design for 6 times that force. The reason why you need to do that is the fact that you want to make sure it's the last thing to fail in your design. As a structure will go up or start to heat up, the precast moves out and slowly weakening the steel, so you don't want the steel to fail first. As that steel fails, it will start to bow down and pull the precast back in, meaning that it won't squash the firefighters that are trying to save your building. Another key element of safety, especially when you're putting these buildings up, is the fact that you want to make sure it's braced in its first solution. When it goes up, it's particularly unstable as you haven't necessarily connected everything to it. So you want to make sure you've got at least 2 props for every precast panel, or something tying them together to make sure they're stable as soon as they're there. As if you've got one prop, it's very easily that one prop can fail. That's why you need 2 areas of support to stabilize the structure. Now, if we're going up into bigger buildings, more than just that low rise, they're really good for replacing cores and big external shear walls. However, there's a couple of careful considerations that you need to look at. In a big long shear wall, sometimes it's really good to make sure that you're not necessarily joining it up, as you can have additional forces from that wall acting as an integral element. It means that you'll need a lot of ties together. But if you're not tying it up directly, you need to make sure you've got enough tie in the slab to allow for those robustness forces that we talked about earlier. So if you use one element, you don't lose the whole building. If you can't do that, there's also another way, is if you've got complete control of the joints, you can lay it over like brickwork. As if you lose one area, there's another load path for that structure to go to. But you do need to make sure, especially when you've got those 2 elements together, there's additional forces in that racking load. As when that building goes up one way, you can see there's a rotational force. So you've got the 2 walls together and they're connected to a slab with a doweling system. And as they rotate, the dowels move in different directions. So you need to make sure those dowels are further enough apart that they're not going to shear off immediately. As they're further off apart, the more bending you get in the slab before this area becomes critical. But just something you need to watch out for is looking at how that connection is going. Where's that first dowel? And how far and how much stress am I going to get from the rotation that I'm seeing in the design? Another careful consideration that you need to have when designing a wall solution is how much weight can you lift? As you have this giant area of concrete, it can have a lot of mass in it. So you need to make sure that you've got a crane capable of lifting them and transporting them. So a lot of the time you need to go back to the contractor that's actually supplying the design and saying, how much can you lift? So how much do we need to break up the precast solution? A lot of the time you're trying to keep them sub 10 tons. As anything more than that, it's going to be a lot heavier and harder for them to lift. And even in some sites, it becomes even less. So it's always worth looking at and saying, how much can you actually lift and how big a panel can I have before it becomes a problem? So transporting and lifting has a lot of restrictions on your chosen wall solution and your panel breakup. But if you're talking about it replacing a core element, there's a lot of careful considerations as you've got two balance butting up to each other. Typically in in-situ design, you have good corner detailing. You have walls going around and tying everything together. Now, this is not only just in design, but also in your analysis. As if you designed it as integral, that's not really how it's going to behave. It depends on how you're stitching it together. So typically you want to have a small gap in your analysis software to mimic that soft behavior. Now, there's two ways that you can connect it. The more traditional way is joining together with little stitch plates. Now, this is becoming less and less common due to those stitch plates being highly critical, and typically you want to make sure they're the last element to fail. So you need additional safety factors when designing them. So typically I design them as a non-ductile element with additional safety factors to make sure they're not going to fail in my design. And I also model them in so I can get the direct forces that are applied to them. It's getting more and more required to do a wet stitch. So what does that mean? You mean you've got a gap in your wall. So you've got a precast wall here, maybe a 1 or 2 meter gap, which you pour as in-situ concrete to make sure that your structural element behaves as an integral piece. What you could also do as well is key in your design, as keying in structures laying on top of each other will mean that you'll have a more integral approach as you have a bit of concrete that it needs to shear through. This can significantly reduce the force on those stitch plates or the wet stitch that you need to design. And as we're talking about lateral forces, the connection to your core is something that probably needs the most careful consideration, especially in a precast solution. But it doesn't really matter if you've got precast walls, in-situ floors, or precast floors. That connection is highly critical as you have a series of dowels between it. That dowel is the only thing that's tying the floor to your wall. So you need to make sure it's got enough shear force to transfer the load that you're putting into the wall per floor at each floor. Also make sure that when it's trying to pull away, it has enough capacity to not tear out. So you need to make sure you've got enough dowels, either top and bottom, in that element to make sure it's not pulling off the wall. Similar to the wet stitch that we talked about, there's a lot of high stresses that need careful consideration. And as they're elements that you don't want to fail, again, they're elements that you want to have additional safety factors in and making sure you're designing them in a non-ductile event. You want the wall to fail flexually as it would in an in-situ situation and not fail at that critical junction at that connection. And other elements in the structure will start to fail, so you'll see the damage, allowing the building to stay safe and having that life safety so people can evacuate before the critical event. If you're interested in learning more about some of the design rules that you go into when designing a precast building, I've got a link to a video here. If you're more interested in steel design, I've got a link to a video here. Both of these would be relevant for a precast solution. And if you're interested in supporting the channel, there's two ways that you can do this. You can either do this through becoming a YouTube member or a Patreon member. Without the support of my YouTube members and Patreons, this type of content would not be possible. And as always, stay safe, keep learning, and I'll see you next week. Bye.